Okay, so on Manuel's money plan, I have the 0 and 192, that's where we started. It's in a curly braces, that's to notify your calculator that you're doing a recursive routine, which just means you're adding to the time before it. So for answer 1, we add 1, because that represents my weeks. But for answer number 2, I subtract 35, because he is spending $35. So I filled in my table. Now on this one, I made it discrete also. However, you could make a real good argument for the fact that Manuel probably did not spend all $35 on one day. So if you connected the dots on this one, that makes perfect sense. They didn't give us enough information for us really to know. It could be that Manuel is paying some sort of payment of $35 every week, that he borrowed some money or something, or let's say he bought something at Aaron's Rent-A-Center, and every week he has to pay $35 on it. So it could be discrete or continuous. We don't have enough information. So I just left my non-connected, but that's kind of what it looks like. Then on problem number 11, what operation did I repeat in my recursive routine? Well, for answer 1, it was repeated addition. But for answer 2, it was repeated subtraction. So the question was, how does repeated subtraction look on the graph? It's a decreasing line. How much money after 8 weeks? I got $812. On week 13, he has $637. Now, number 15 was kind of a weird question because it said, if Manuel needs $100, well, Manuel could just stop spending right now and he'd have $100. He has $1,092. But I went ahead and found out he has to stop spending at 28 weeks. Let's say if it goes below $100, the bank's going to start charging him. He would have to stop spending at 28 weeks. Because 29 weeks, he drops below. I think that's right. And then after 19 weeks, he had $427. Last question. If you're looking at Susan and Manuel's money plans, which one looks like walking away from the CBR or the motion detector? Walking away. What does the line look like? It'd be Susan's, because that's the increasing line. And walking towards would be Manuel's. What about standing still? Do either of these look like standing still in front of the CBR?
No,
okay. Right, because that would be constant. So if we were Susan, what would we have to do in order for our graph to stand still? Not put any money into our account. Not save $2.50.
Or it still wouldn't be continuous because they're discrete points.
But they would be discretely constant. They could be discretely horizontal. So she would, once she got to that certain point, she would just stay there if she didn't put $2.50 in her bank account. And for Manuel to stay constant, he'd have to stop spending money, right? And then that would make the line stay constant. Okay, I'm going to give you your assignment, and real quick, so let me show you, and I want to show this on the video too. On your assignment, you can omit problems 1, 2, and 3 because we did not cover the activity that explains those things, and it's fine. You know enough to not need that. I don't know. But on the back, I flipped this onto the back. I want you to look at this because it's just a way of notation. I don't want it to freak you out or scare you. But this information here, this A to the n-1 stuff, all that means is recursive routine. It's not really mathematical. It is just a notation to tell you we're recursively subtracting 20 from the number before. This one would mean we're recursively adding 20 to the number before. And then this notation, A sub 1, in pre-cal, I don't know why when Texas rewrote the TEKS, they started writing it as A sub 1. We used to write that as A sub 0. That's the amount you had in your first week. So in this particular one, I don't know which graph it goes with, but in week 0, I have 300, and every following week I'm subtracting 20. Does that make sense? That's all this notation means. So don't let the notation freak you out. It's just matching. I think you'll figure it out now that you know that. So that's it. Omit numbers 1, 2, and 3, and then finish the rest of it for homework.